From the previous equation, after simplification, ρ21 becomes A21 N2 by B12 N1 minus B21 N2. Dividing numerator and denominator by N2, it becomes A21 by N1 by N2 B12 minus B21. From Boltzmann law, we know N2 is equal to N1 e to the power minus E2 minus E1 by KT. Or we can represent the difference of these two energy levels, E2 minus E1 is equal to h nu. So N2 is equal to N1 e to the power minus h nu by KT, where K is the Boltzmann constant. Thus N1 by N2 becomes e to the power h nu by KT. So putting this value of N1 by N2 into the equation of ρ21, this becomes A21 by e to the power h nu by KT B12 minus B21. So dividing both sides by B12, numerator and denominator both, A21 by B12 is equal by e to the power h nu by KT minus B21 by B12. Now from Planck's blackbody radiation formula, the energy density becomes 8 pi h nu cube by c cube into 1 by e to the power h nu by KT minus 1. Comparing these two energy radiations, we can write A21 by B12 is equal to this part, 8 pi h nu cube by c cube, and this one is B21 by B12, this one is equal to 1. So B21 is equal to B12. Thus stimulator emission coefficient, Einstein B coefficient for stimulator emission is equal to the Einstein B coefficient for induced absorption. So we can say the stimulator emission is a special case of induced absorption. Now come to this part. This is the formula. We can see A21 by B12, it is directly proportional to the cube root. This is directly proportional to the nu cube. B21 by B12 is equal to inverse, it is inversely proportional. B21 by A12 is inversely proportional to the frequency cube, nu cube. This is the frequency, its cube. So B21 by A21 is inversely proportional to the frequency of resonant radiation. Therefore, higher the frequency, smaller the value of B21. That is, it is comparatively difficult to obtain the stimulated emission of higher frequencies. Always remember, it is comparatively difficult to obtain stimulated emission of higher frequencies. Pumping and population inversion. Transitioned atoms with electrons don't stay for longer times in excited state. This is the lower energy state. There we are considering three energy states, E1, E2 and E3. There are electrons for some substances or systems where they remain in the excited state for longer period. Such systems are called active systems or active media. These are generally compounds or mixtures of different elements. Now, generally electrons exist in lower state called ground state E1, and the atoms is N1. This is N1, this is the ground state. Now, when a photon of energy h nu is incident on the system, due to the process of absorption, when electromagnetic energy equal to the difference of E3 minus U1 are incident on atom, electrons jump from state E1 to the excited state E3. E1 to E3. This is the difference of energy. This is the photon. Atomic lifetime of an atom in excited state is very less. It is almost equal to 10 to the power minus 8 second. Usually, most of the atoms with electrons loses its energy due to spontaneous emission. This atom will spontaneously come to the energy level E2 and it will lose its energy. Returns from E2 state to E1 state, and the number of electrons in E1 state is N1. So from E2, E3 to E2, the loss of energy is very less. The less emitted energy by atoms with electrons is called thermal energy, which is absorbed by the medium itself. The transition from E3 to U1 is called non-radiative or invisible transition.